somewhat interesting. The book is called Ready Player One. Any of you heard of it? So the guy who reads it for the audiobook is Wesley Crusher. What's the guy's name?
Oh my gosh.
He's on Big Bang Theory.
Yeah.
No, not Sheldon.
my
He's
gosh.
he's Sheldon's arch enemy on there.
Oh,
What's his?
Will Wheaton.
Will Wheaton. Yeah. So Will Wheaton reads the book and does a pretty good job. But the premise of the book, and Steven Spielberg's making a movie of it. It's supposed to come out next year. I mean, it's like legit. The book is really good. The premise of it is, imagine if there is so there was like this super rich guy that effectively made, well, I think it was chicken or the egg. He became rich because of this. He created like the world's best MMO video game. Okay, but it wasn't just a video game. It was kind of like Second Life, but Second Life done right. So people literally lived in this game world, and they were doing quests and things like this. And when this guy died, he had put an Easter egg into the game that was like the ultimate quest, that if you were the person who completed it, you got the company for this thing. So that created this whole ecosystem outside of the game of companies that would hire like the best game playing talent to try to do that. And then you had individual people who were trying to be like the best in the world at doing that. So this follows the path of like this one guy and like the 3 or 4 other people he meets that are like on this quest line in competition, and people are getting killed over it and stuff like that. But it's pretty interesting.
What's it called?
Called Ready Player One.
see that Leonardo DiCaprio got his first Oscar?
I heard. Yeah. Is that?
I heard his acceptance speech is really lame.
I thought he gave. I heard he gave some sort of like.
He's talking about the
Environmental,
environment.
yeah.
It's
Oh.
funny before that though, because Chris Rock was hosting it, and then Louis C.K. was on it. So they made an Asian joke while there was little Asian kids on the stage and stuff like that.
So.
And they kept making fun of Will Smith and like how they were protesting it because there wasn't enough black people.
Right.
That's because they kept making jokes about it and how Chris Rock was black. They made one comment about how maybe it's because you're not good enough, which I thought was kind of funny.
Yeah. No, I get it. I guess if you hadn't already noticed, I'm kind of the opinion that people are way too sensitive about stuff. So I gotta go the whole other extreme and just make fun of everybody. And eventually they'll get thick enough skin that they just won't worry about it. Okay, so let's see here. We have our towers and everything mechanically working now, right? We just have to put our logic in. Is that the correct state of affairs? Because right now you can put disks on top of other disks that are against the rules, right? I think that's the current case. So we'll finish writing that logic, and then we're going to start binary trees. And then we'll have to have a really hard assignment between now and Thursday for binary trees, and then probably an equally bad assignment over the weekend. It's not this. It's nothing. Garbage. It's complete lack of effort.
I'm gonna be gone starting Saturday.
Well, you have to do it. You have to do it Friday.
That's fine. Just so you know.
Yeah, or Thursday. It's Thursday and Friday, so you have, well, not 48 hours, but 37 hours.
Is there a movie called 48 Hours?
Probably.
He cut his arm off for that long?
No, he was gone for 127 hours. Or like,
It was like in the end that he decided he needed to cut his arm.
He had his arm cut off for that long.
This was out of context. Why did he cut his arm off?
He was like climbing out in the desert.
Oh! I think I.
Like he's got his arm pinned under the
And eventually, that was the.
yeah, he had to cut his arm off.
Yeah. That's actually an interesting question. How long do you wait? You know, kind of like if you get stuck in an elevator, you know, with like 5 or 6 other people, how long do you wait till you turn towards cannibalism?
Well, like in that case, with the arm thing.
That would be a great movie. It's like, wait, the other, I think I hear people working on it. I just can't wait. This got dark so fast. All right, so we have the ability to, but I think we can put stuff. Okay, so we need to fix that. All right, so now when we try to make a move, we need to make sure they're allowed to make a move, right? So the disc that's currently on top of a tower needs to be either empty, a move is then allowed for anything, or it needs to be smaller than the disc we're trying to make the move on. All right, so let's go back to our tower fragments. So here's our pop disc and here's our push disc. And our push disc is just haphazardly adding a disc without checking, right? So when we pop a disc, are we, this is the disc we're adding. So let's first put in the logic whether or not we'll allow the move. And we'll just, for right now, let the disc just be lost. But if we don't allow the move, we probably need to go ahead and either undo their pop or just leave everything alone and not actually change the, they still are going to have a push. They have to just pick a better location, one of the two. So right here, we're going to, before we push anything on here, we're going to have to ask the question, are we allowed to, that's weird. Oh, it just closed it for us. Okay. So here's our actual discs. So this guy is the representation of our stack, the discs. All right. So, and I think aren't we dealing with it upside down? So it's actually the end is the beginning. The top of our stack is the end of this linked list. All right. So we'll have to ask a question in here. First of all, a disk itself looks like this. And that's just a view. And when we create a disk, we have our disk guy right here. We change that guy's width and stuff, don't we? So can we do this off of the width of that disk? We might be able to. Let's find out here. So we'll come back to our tower fragment, and let's start off by just saying system.out.println. We'll put in a bunch of asterisks so we can see it. Concatenated with disk dot get width. Let's see what that looks like. So that guy had a 360 width. So this guy should be wider. It's not. Okay, so that's the width of the tower itself. So we really need the label's width. Yeah, that's why that guy is. So can we get the, probably pull it off this way. Disk dot get subview, or is it just subviews? Find view by ID. So we're going to say label L is equal to the label version of the Oh, it's not called label in this. It's called text view. Of disk.findView by ID r.id dot disk label, and then we should be able to say l.getWidth. Let's see what that looks like. The width of the actual label. So we'll pop, we'll push, that's 120. We'll pop, we'll push, that's 210. All right, that looks like it's usable, right? All right. So then we'll say int width, well, we can actually, we just use it directly. So we'll say if, so we also need to we really actually don't need the label itself. We just need the width of the label. So we can probably, let's just do new label, new disk width. Be very careful about how I type that. We had an incident last night in 518. Remember that with the div, the mistyped div?
There was that one. There was another one.
Oh, there was another one too. It was bad.
Yeah, I can't think of what it was. It'll come to me.
Oh. Yeah, the C and the V are very close to each other on the keyboard. So it was about a 9 p.m. incident. All right, so this is going to be l.getWidth. And then we also need to get the width of the disk at the top of the stack. So that's going to be text view top label is equal to the text view version of this dot the disks dot get last dot find view by ID r dot ID dot disk label. And then we'll say int top disk width is equal to top label dot get width. So now we have our two widths there. And we're going to go ahead and let them make this move if the new disk has a smaller width than the disk that's already there, right? So if new disk width is less than top disk width, then we'll go ahead and do our thing here. All right, so let's test this. This should at least prevent us from making illegal moves. Although I'm pretty sure that we're going to still toggle between push and pop. So we're going to need to conditionally do that. We might want to have our push disk return a Boolean, whether or not it was successful or not. And then we can respond to that over on the side where we were responding to the button clicks. All right, so we'll go ahead and pop this, push that. Whoa. Oh, we need to check to make sure it's not the empty. It crashed because this did not go well when our stack was empty. So we need to go ahead and so this is probably going to give us so we're going to say this. If int top disk width is equal to 0, then we'll say if this dot the disks dot size is greater than 0, then we potentially will update the width of top disk. So we'll start top disk off, the width is 0, which means that everything should be able to, well actually 0 is going to be bad. So let's start off at -1. Then we potentially will change it. So now we're going to say if top disk width is not equal to -1 and, so as long as it, we don't want to say not equal to -1. We want to say or. If it's equal to -1 or, in either one of these cases, we're allowed. So if it's equal to -1, we'll just let them do it. Otherwise, if we're allowed to do it, if the new disk is smaller than the disk that's currently on top, we'll let them do it. So this should let them. Okay, so we're losing our disks now, but that's okay. So now we can go ahead and change push disk to return a Boolean. If we successfully push something, we'll return a true. Otherwise, we'll return a false. All right, so this says whether or not the push worked. So let's go ahead back to where we're calling that. So that should be in stack activity. Is this where our, no, it's going to be in our fragment. It's where our button push is, right? Up here. So here's our on-click listener. If it's currently equal to pop, we're going to pop the disk. And we're going to need to remember the disk we popped. So when we pop disk, aren't we setting our, that's this guy down here. Do we set the, yeah, here's the pop disk. We're remembering what we popped. And then we'll go ahead and toggle, that's fine. Otherwise, we're going to try to push the disk, but we're going to have to get a success on that. So if push disk, if that returns a true, then we'll go ahead and zero out the pop disk. Okay, but only if we successfully made the move. Otherwise, it'll still have the disk up in the core, and then we also won't toggle the button, so we'll have an opportunity to push it someplace else. We probably want to give them a little message too, so we'll look at how to do something called a toast here in a second. We'll pop that, we'll push that, pop that, we'll push it there, not allowed, but we should be able to push it there. So now we can go and do our thing, but when they make a bad decision or a bad move, Android toast message. It gives you a little pop-up like this. All right, so basically something that's going to look like that. So we'll go ahead and create a toast. So we'll actually do it here in push disk. So we'll say toast dot make text, and our context, actually it looks like we have a context here, right? this dot get context, and then what was next? The message, and then the duration. So illegal move and duration. Let's just think it's in seconds, or is it milliseconds? Toast. Oh, we can actually give it lengths like that. Toast.length. Length short, so that'll be a relatively short toast. So as a review, what must this guy be, length short? What kind of animal is that? Tell me everything you know about length short there in context of what you see right here. Okay, it's probably a constant. That's something we haven't talked about, but because it's in all caps like that, that's probably a constant. So move past that, but that's probably a true statement. What else? Is it a method or a field or a constructor? It's a field. How do you know? Yeah, no parentheses. All right. Is it an instance field or a class field? Class field. How do you know? Call it with the name of the class. All right. And what we see here isn't necessarily we don't get any information about what the type is, but now we kind of know where it fits in the world, right? This is our duration. I don't know what duration was in, whether that's an int or something else. For all we know, it's a toast time slice or something. But what does this tell us? Well, whatever. All right, so in any case, this makes our toast text, and then we can go ahead and tell that guy to show himself. We don't need to store it any place, so we'll just use it directly. So this creates a message in the current context. Message will be illegal move, duration will be length short, and then we'll tell that message to go ahead and show itself. So this should just kind of pop up on the screen real quick like. So what's the context of this thing? Just a random Mountain Dew sitting there? Anybody want a Mountain Dew? Is it from you? So what's the? Tell me what's explain.
I just thought it was funny.
So just in general. So is there a so it's not cat related. It's just funny. Oh, I got you. Okay, I get it. So that's the sentiment there. So you shouldn't get homework for the weekend either.
Right.
I get it. All right. So hobbit, hobbite. Oh, I get it. But how shouldn't this guy be like a lot smaller?
Probably.
But yeah. So maybe wouldn't give context for these guys. So were you on bubble water when you? I was hitting the bubble water pretty hard. All right, so let's pop there. We'll push. Now let's make an illegal move. So there's our illegal move. Goes away. Kind of tells us we weren't allowed to do that. And now we should be able to start doing stuff. We'll make another illegal move. There's our illegal move. We'll push there, and we can still do stuff while that's popped up on the screen. So a toast is an asynchronous call. It's a non-blocking call. So we can, if I go ahead and try to make another illegal move, I should be able to push over here while that guy's still up on the screen and that stuff. Okay, so now after each individual move, we need to check to see if there was a winner. Right now, our board is self-governing in terms of our moves, but after each move, we need to know whether or not there was a winner or something like that, right? Okay, so how do we detect if there's a winner in the context of our game? We're not going to make ours as flexible as the one on the website that allows you to choose the number of starting discs and that kind of stuff. So in the context of our game, how do we know there's a winner? Go ahead.
All three are on top of each other in a different spot in the first one.
So that means I can have a winner if they're all here in the middle?
Is that where it started?
It starts over here on the left. So winner is only when they're all on top of each other over in the last tower.
Or in the
No.
no? Oh.
You don't even know how to play this game, do you?
I do. Why couldn't it be in the middle?
Because that's not how the game works.
Yes, it is.
No, it's not. You're saying that's a winner.
Yeah.
It's not. That's not a winner.
I'm sorry.
I mean, you would be very bad at the tournament Towers of Hanoi death matches. You'd have way more things to worry about than grass outside. And bubble water.
I'm not worried about bubble water.
Well, you should be.
Oh, is it bad for you?
I've just been told. So, this is dangerous stuff.
You're drinking bubbly yellow water right now.
No, that's not. Yeah, I'm not drinking it yet.
Oh, I thought you opened it.
No, I didn't open it. I'll put it in my fridge. In my office. This is dangerous too. This is some red raspberry tea that Randy in the cafeteria brought in and told me to try it.
Yeah, somebody at our men's retreat made some special tea, and it was like something I've never heard of before, and people were trying it.
I have some of my grad students bring me in special tea as well.
Like, if I haven't heard of what's in it, I'm not gonna try it.
You're the guy who won't walk on the grass.
Yeah.
So I'm sitting here in a class, and a lot of my grad students are like Indian, Pakistani, Saudi, and they bring like pots of tea that they're drinking. They're sitting around drinking. They're filling each other's cups. It's weird. So they give me, and the tea flavors are like the tea would be like cumin, like tea with cumin in
I
it.
saw somebody drinking, it's like they put Cajun powder, chili powder in their water.
Yeah,
And didn't even like heat it up or anything.
that's how they fight diarrhea over there. Gotta keep the spice levels up. I mean, the tea is interesting, and a lot of times they put milk in like this weird tea. So I think Thai tea typically has milk or cream in it. I don't know what else is in there, but no chai. I'm not saying that. I'm saying that Thailand. If you go to a Thai restaurant, the tea they have there typically is like a milk-based tea, which I guess would be similar to like a chai latte. I mean, chai lattes are good, aren't they?
Have you ever had an iced chai before? Those are my favorite.
Yeah, but I drink them too fast. That's the problem.
Ask for a light on the ice and they give you more.
Well, yeah, but if I drink it hot, then I can go. Although I drink a lot of coffee, so I've built up a pretty good tolerance. I could pretty much chug coffee.
Do you just get like normal coffee, or do you have to get fancy coffee, like espresso?
Oh, I mean, it depends. If I'm at like a Starbucks and I'm not paying, I'll get like a caramel macchiato or something like that. But I mean, what you call fancy coffees, or most of that is milk. It has like two shots of espresso in it. So it's like 2 ounces of coffee. An espresso has actually a lower caffeine rating than a lot of coffee beans. So it's a total hoax. That doesn't mean it doesn't taste good. Just saying that if you're the person who's looking for espresso to wake up, a caramel macchiato is not the way to do that. It's good. That's not your tool to.
If you want coffee to wake up, you get like the drip coffee, where it's like impossible to eat or drink.
Yeah.
It tastes terrible. You ever had drip coffee before?
Well, you can get like Ethiopian coffee and stuff like that. You're talking about coffee where they make it. It drips in just from the grounds. They put the filter in on top of the cup and drip it through. Or are you talking about like a Mr. Coffee machine drip coffee?
No.
I mean, I'm not sure at what level of sophistication we're dealing with here.
Where it's like really, really strong because it's like very warm.
Well, you have French press. So French press coffee, you put it in there and then you pressure it through. And then you can go up and down a bunch of times and really just But Ethiopian coffee, they put the grounds in the coffee.
It's like dirt kind of.
Yeah, that's the way it should be.
I had that one time. It tastes like dirt. But it woke me up really quick.
You don't seem like the type that would drink dirt. You got tricked into that one, didn't
Yes,
you?
yes.
Yeah. All right. Bubbles in the water or dirt in the coffee.
I don't drink coffee either.
Well, that's not an answer. You have to drink one of them. Do you drink tea?
Yeah.
Dirt in the tea. Dirt in the tea. No bubbles though. Just dirt.
Or drinking swimming pool water.
Probably go with the bubbles.
You good? The bubbles over the dirt in the tea.
Almost don't do anything to you.
See, there's a coffee I've had that's made. I'm trying to think of the name of it right now. It's escaping me, but it's really expensive coffee, and it's processed. It's elephant dung coffee. So elephants eat the beans. It goes through their everything, and then they take it out of their leftovers, and then you make coffee out of that.
Why? You paid for that?
Yeah, you pay like top dollar for it.
Yeah,
Why?
that's a
Why
dumb
does it make it any
mistake.
better
Here,
than
let's-
normal coffee? It's just gone
Sure,
through the
like
elephant.
that same process done with another animal too.
Yeah, I think there's like monkeys, some kind of
Yeah,
So
and
like
I'm
if I
sure
have a
it's
dog
like
at home, I could try
really
that.
good.
elephant dung coffee in grocery and gourmet foods. Oh, it's in here. Look at this. Kopi Luwak coffee, wild gathered, 100% pure, 16 ounces for $400.
Look how many stars it has though.
Well, who's gonna buy that? Everybody, I'm sure the people who gave the crappy stars said, "Wait a minute, I just paid $400 for
So
not."
we gave it a 5-star though. So that's like
Yeah, that was the owner.
actually meant
The
to
owner
be.
did that. So yeah, it's legit stuff.
So if you buy an elephant, how many
Yeah.
16 ounces?
Well, no, I think it's a combination of the elephant plus like a certain kind of bean that breaks down as part of the elephant's digestive process. So I think it's a combination of an elephant plus a certain bean. I don't know if you could just feed the elephant any kind of beans. I'm not sure if that's the case, but it's something. I mean, how do they? Have you ever considered how they discover some of these things? Like at some point in time, somebody came across a pile of elephant crap and said, "Are those coffee beans? Let's rinse those off."
Still good.
How bad can it be? Yeah, exactly. All right, so you were giving me a bad answer about how we detect a winner.
Yeah. Apparently I don't know how to play that.
Yeah, so now you know. How can you give me a better answer?
When all three are right.
Okay, and how do we ask that question?
Well, it's Tower 3, isn't it? What
Yeah.
Something you do with them being in the correct order in Tower 3.
Okay, and if we go to our stack activity, we know about our 3 towers, right? Well, actually, our tower core knows about those 3 towers. So can't we ask a tower how many discs it has? If its number of discs is 3, it's a winner as long as it's tower 3. Only tower 3 though, and not just any tower. By your rules, you win right at the beginning.
Why would it matter if it's the middle one or the right one? There's no difference.
There is a difference.
It's gonna take the same amount of moves to win.
Well, no, because you can't win in the middle.
I just don't understand why. Like, why does it matter?
I mean, maybe you're playing by some backwoods rules, but we're playing by international Towers of Hanoi tournament deathmatch.
The sad thing is that's probably an actual.
It's probably-
A bunch of kids with like ones that are like this big.
It probably is. You're probably right. Unfortunately, you are probably right.
Are you gonna play Monopoly and collect $200 every time you go halfway around the board?
Yeah, exactly. You just pick up money in Monopoly anytime you want.
That's not the same thing at all.
What do you mean?
Why does it matter? Because
Yeah, I bet you your house rules for Monopoly were really messed up.
you get 400 if you land on go.
Yeah.
Okay.
What happens? I guess in your world, what happens if you don't land on go?
You get $200.
Oh, just period. Whether you pass go or not, just you get money.
No, when you pass go. I don't see how that's anything like this tower thing, because it doesn't affect, like, if it had been set up ahead of time, you get $200 when you pass jail, it's not going to affect the.
No, but it was. They set up the game to say that you win when you get to the last tower. Just like in Monopoly, they said you get $200 when you pass go.
Yes.
But now you're saying, well, why can't you just go to the middle tower? Well, why can't you collect $200 when you land on any of the red properties? That's a modification of the game.
I guess you're right.
At least bubble water makes sense.
I'm looking up the official.
Trevor's right, though.
About
It
what?
would take the same amount of
It would take
moves
the
to
same
get it to
amount
the
of-
right side as it would to the middle.
No, when
And
you,
Monopoly's different.
It's not like you can only move it one space at a time.
Right. No, I mean you're right, but that's not the game.
I understand.
But Monopoly has more objectives than moving 3 rings and 3 little things sticking out.
Yeah, you say that to the deathmatch people.
I can't find anything on
I
that.
mean when you're playing Towers of Hanoi over a open volcano, I'm pretty sure that's where they did it this year. There's just so much lore I'm creating around this.
just get kicked in the head.
Well, yeah. Well, I mean, I think there's even also amount of time because you're probably on like a thing made of bamboo over the volcano, and that's going to be charring. I would assume, and then you also have the stress of the volcanoes rumbling and stuff. At what point is it just game over?
You're right, so I looked it up and it says all the pegs must be moved from the leftmost peg to the rightmost peg.
I was pretty confident I was right. So I'm not sure that required Google. You probably used Bing, my guess.
No, I use Google.
All right.
Is there any rules that say that there can be more than 3 towers?
There's not. There's actually plenty of modifications of the game that allow basically an infinite number of towers and an infinite number of starting discs.
Makes it easier. It's
So
better
that,
when you have a lot of starting discs.
that makes sense. That has to be the most right side, because if there was more than 3 towers, there wouldn't be a middle, really.
That's true.
I mean, the legend it was created off of says that when the final move was completed, the world ended.
Yep, that's the volcano thing.
Wow.
Haven't people completed this before?
They're gonna make this game way harder. I mean, all right. So let's go ahead and ask the question so we can talk about binary trees. So after a, let's see, we need to go back to our stack activity. So after actually it's not stack activity. Where's our button in tower fragment? All right. So after a move, we can do this up here in our button. Okay, so if we're able to push a disc, we'll reset the tower buttons like we did. Now we need to check for a winner. So what does check for winner do? It's going to ask if the third tower has 3 discs in it. Do towers know how to advertise the number of discs that are in them? Actually, they do sort of, I guess. So we can say if TOH dot tower 3. Now, right here we have a linked list called the discs. So really for tower 3, we want to know if this guy's number of discs is equal to 3, right? Do we have access to that guy? Right down here. Can I say dot the discs?
Aren't we still on the click list there?
Am I still aware?
The unclick lister?
Yeah, I'm not saying this. I'm saying TOH core. So I'm grabbing the tower from TOH core. So this is a tower. Do I have access to that tower's the disks, or do I need to provide a getter? It's a private variable. What does it mean for a variable to be private? Within its class. And what class is this guy in? Tower fragment. And what kind of dude is tower 3? It's tower fragment. So even though it seems like we shouldn't be able to access it, we actually can access it because we are in the same class. We're not in the same instance of the class necessarily, okay, unless the button we clicked was tower 3, right? But we are in the we are inside of that class. Dot size is equal to 3, then we have a winner. So we'll say toast dot make text this dot ooh. We need to have our context. Here. We're going to cheat this just for the sake of time. Yeah. We'll do it after we actually make a move. So this is our make move. We'll go ahead and ask here. This dot get context. Winner. Toast dot length long. And then we can do whatever it takes to end the game or something like that. Okay. So yeah, my voice is getting to the point where we're getting dangerously close to winning Towers of Hanoi, and we already talked about what happens then.
It only happens in 64.
64 discs?
Yeah, and that would take you 9.22337 to the times 10 to the 18th power moves.
There actually is an algorithm for
Yes.
solving the problem.
It's
So we can write a program that will start with 64 discs and make all the necessary moves,
and then the world.
and then the world's over. But if it's a computer program that did it, is that still a thing?
True.
Or is that not,
Oh, you could say
I don't know,
human
part of the
human
volcano
program
lore?
then.
What's this?
Human program.
It's true.
Have the program do it up to the last move.
And then,
It
poof,
has to do that.
that's right. And how many towers are there? You said 64 towers?
Yeah.
64 towers and, no, you said 64 discs.
Yeah, 64
Yeah,
discs
64
and 3 towers.
And just 3 towers?
Yeah.
Oh, that's
It's 7 of them. and
That's pretty
46
legit.
seconds.
That would be a tough game. Okay, so this should now show us a winner, and then we'll talk about binary trees. So we'll pop. And let's see, what do I need to do? I need to do that. Pop. That. Pop. That. Pop. That. Didn't I just do the move?
Would size be equal to 2?
No. I don't think so. Here, let's print out the size. I actually have a theory. I wonder if our towers are backwards. Oh, just run it again for good measure. Oh, we had a winner. We won. I just never showed it. I was testing all of you. Failed miserably. Just miserably. See, it's the volcano fumes. See, every year at the World Championships, I channel the volcano stuff, I guess. You got to be there. It's a thing. See, you just saw the way I handle things on the volcano. So you got to go quick because the bamboo burning things. What's up?
The bamboo burning?
Yeah, you missed the bamboo burning. I mean, you're playing this game on top of bamboo that's bridging the gaping, chasm. Chasm. It's chasm, right? It's chasm. He hasn't been there.
That's outside.
Yeah. So the bamboo is like charring because you're over heat.
Basically, if you don't finish it in time, you die.
Well, yeah, or if you do, and you do finish it in time, and you can't make it off because you've got to be in the middle. And I don't know if you noticed, but I'm heavy. So you put me. This bamboo is, I don't know how far apart, how wide is the opening of a volcano?
About a football field.
Okay, so football field. That's a lot of. First of all, it's a lot of bamboo. That's not one piece. You got to bind that together. What are you going to bind it with?
Rope.
They don't have staples in the.
Like a desk
This
staple?
stuff. We play this in the jungles. This is the Ring of Fire. Where is this? So with Malaysia and stuff like that. Is that it's the Malaysian jungles.
They're the only government that would allow you to do it over a volcano.
That's right. Like was that from the movie? Was it Blades of Fury? Blades of Glory. The Iron Lotus. North Korea, the only country where you can actually try to do the move. That was a great scene in that movie.
So they only have this competition every few years when the volcanoes active.
What's this?
So they only have it every couple of years when the volcanoes active.
Yeah. You got. Have I shown you this? See, the bad thing is it doesn't look incorrect because I have the width of the Hulk, I guess. Like, huh?
Is that a typo?
I don't know. I didn't make it. I think it's supposed to be computer science. You're right. It is a typo. This was Tony Spencer. We're probably lucky she spelled most of the words right. To be honest. All right, so let's talk about binary search trees. All right, so up to this point, we've talked about linear linked data structures, and now we want to talk about non-linear linked data structure. So this guy is a non-linear linked data structure. This is guaranteed to store elements in order. And I put that in quotes because in order is going to be in the dependent on how we traverse the tree. So we're going to be doing a couple different layers of looking at this. We're going to initially implement a binary search tree. Then we're going to do traversal algorithms, in order, post order, and pre-order, post order, in order. 3 different traversal algorithms for how do we walk through a tree. And then we'll talk about performance of using a binary search tree to search stuff. So 3 different levels here. All right, so let's look at this by example. So when we first add an element to the tree, let's say we're adding in a 5. Shrink that down a little bit. Okay, we're adding a 5. So now that becomes the root node of our tree. Okay? Now, when we add our next node, let's say this is a 7. We drop that 7 into the top of the tree, and then we ask, where should it go? Everything to the left of the root of a root node is less than or equal to that root node. Everything to the right is greater than or equal to that root node. Every child has at most 2 children, hence the binary. Every node has at most 2 children, hence the binary search tree. Okay, so this guy currently has 0 children. We try to drop the 7 in here. We say, okay, well, this spot's not available. It's already taken. Should a 7 come before the 5 or come after the 5? Is 7 less than or equal to 5, or is it greater than 5? It's greater, so we'll try to add it to the right. Can we add the 7 right here? Yeah, there's an open spot. So that guy just became the right child of the 5. So now we'll create another guy. Let's do another 7. Should a 7 come before or after the 5? After. Should a 7 come before or after the 5? So we said, or before or after the 7. So we said everything to the left is less than or equal to. Everything to the right is greater than. You can decide to do that the other way. You could say everything to the left is less than, everything to the right is greater than or equal to, but you just have to be consistent throughout your entire tree. So we'll stick with less than or equal to is to the left. So we can't add this guy here, so we're going to say which side should it go in? Should it be the left child or the right child? Well, we're going to say it's the left child, so we'll try to add him to the left. In this case, he can be added to the left. Let me spread these out a little bit. All right. Then we'll go ahead and we'll add a 6. So 6, this should go to the right. Now we're at the 7. Is this less than or equal to 7, or is this greater than 7? It's less than or equal to, so we'll try to add it here. Is this less than or equal to 7, or is it greater than 7? It's less than or equal to, so we'll add it right here. Now let's say we have a 3. Drop it in the tree. Is this guy less than or equal to 5? Yes, it is, so we'll add it right here. We'll move it out there. Do a 4. Less than or equal to 5, greater than 3, so that guy's going to go right there. 2. Less than or equal to 5, less than or equal to 3, this guy lands right here. Make sense? Kind of the rules? Go ahead.
So with the 7, it has 2 child nodes. Does that mean there can't be another node added on the right?
This
side?
7 has 1 child. This is that guy's 7. So this 7 is this guy's child. This 6 is this guy's child.
Okay.
So let me give you a, let's add an 8 so I can show you. So an 8 would go over here, then go over here. Now this 7 has 2 children.
Oh, okay.
Okay. This 7 has 1 child, and then this other, these are called leaf nodes. So when something's at the very bottom of the tree, it's a leaf. Not that important for us, that's just more vocabulary. So this is a root node, this is a leaf node. Okay, so every node has at most 2 children. So this guy has the potential to have a left child and the potential to have a right child. Make sense? So if we think about designing this, what does a node look like in a binary tree? Well, it's going to have our payload. So for right now, let's start this off as, because we're going to write this initially as just the Java program version of it. We're not going to integrate it into Android. So you can, if you want to do this in Eclipse, you can. Otherwise, I would say do it inside of our project here to keep going. So every node is going to have a payload. We'll say it's an integer payload. It's going to have a node left child that would start off as null, and a node right child that would start off as null. Okay, so that is a node. Make sense? What's a binary tree? A binary tree is going to have a node root. That's going to be equal to the root of the tree. So initially this guy is null because it's the empty tree, right? So if we were to have a display function that displayed the contents of the tree, that guy would have, we would have the if statement, if root is equal to null, empty tree, else show the tree. All right, so what function should a binary tree have? It should have a add value that returns nothing, takes in an int payload, and this guy should add a new node to the tree in the proper place. This should also have a function called display. Displays the tree in a reasonable form. Now, let's give an example of what this tree might look like. So what I'm going to do is we're going to display our tree non-visually, at least initially. And even visually, we're going to probably not do too much crazy stuff with Android because I don't want to burn all our time having, you know, these like scroll views that have our tree just keeps getting bigger and bigger. We could, it's possible, but not real productive for us initially, at least. So we want to think about these this is called, we're going to do what's called a lexicographical address. So this is row 0. This is row 1. This is row 2, for example, and then we have a third row as well. All right, so if we try to pinpoint these guys on where they live, if we were to give an address for this 5, we would say he's at 0, 0, right? So let's look at how we might display this guy. So we might say 5, 0, 0, and that's that particular representation of that guy. And then coming off of that, we have a 3, 1, 0. So that's row 1, column 0. So on and so forth. So you could think of this as child 0, child 1. That makes sense? So 3, 1, 0. This guy would then be 2, 2, 0. Well, I got some commas in some places and other things and not in those places. And then we would have 4, 2, 1. Then we would have 7, 1, 1, 1, I guess you can call it. And then we can have 7, 2, 0. And then you can have 6, 3, 0. And then 8, 2, 1. So something along those lines. Doesn't really matter if you use that exact same process, but something that tells you where these guys live relative to each other, because we're not going to be able to visually, at least initially, we're not going to be able to visually show these guys on the screen. Make sense? So your display method should show something like this. Okay? So that might be a reasonable format for your display method. So we can add a value to the tree, which should kind of plinko it into the tree. So I think was it the Price is Right? Is the Price is Right is plinko, or is it Let's Make a Deal? One of the two. Price is Right. So you drop the coin in and it lands in its final spot. So when we drop something in, it's going to go as far down the tree as it can until it lands in the place where it's in the correct order. That make sense? All right, so your homework assignment, implement a binary tree data structure in Java in terms of in terms of nodes and a single binary tree object. The reason why I'm specifying that is once we write it that way, we're going to, I'll just give you a heads up. This might help you think about trees moving forward. This whole thing is a binary tree, right? Couldn't you say that this little part of it is also a binary tree? This little part of it is also a binary tree. So a tree is actually a tree of trees. That makes sense? And that's going to be very helpful when we talk about rebalancing. So when I mentioned binary trees initially, I said we're going to build the tree first. Then we're going to talk about traversing the tree. What is the different ways we can go through this tree? So if we just think about this, 2, 3, 4, 5, 6, 7, 7, 8. That traversal puts it in what we consider to be in order, right? So we'll talk about how to do that and then some other ways to traverse the tree. But then we need to talk about search performance. If we're searching for a value within the tree, how long does that take and how do we defend against it? So imagine, could we have had these exact same values in a binary tree produce a different tree? If we had added them in a different order, it very likely would have produced a different tree, right? So the order in which we add things to a tree directly dictates what that tree is going to end up looking like. So if the moon's aligned, let's say, and we get this tree that's really, really, really long on one side, its depth is big on one side and shallow on the other side, and we start going down that long path, we might end up having a really inefficient search because we might have to go down the tree 30 levels until we finally decide it's not there. Where if we constantly maintained our tree kind of balanced, where the left side was roughly the same depth as the right side, left side and right side were roughly the same depth, then searching the tree should give us a fairly consistent performance. So we're going to be looking at tree rebalancing algorithms through something called an AVL tree, okay? And those are nightmares. And that's going to be probably the hardest assignment you've had to do in any of the programming classes at this point. So we'll make sure we do that over a weekend. All right, so questions, comments, concerns about the homework assignment? Okay, I'll push the current code up so you have the latest, greatest, whatever, and I will see everybody on Thursday.